Good morning, children. Welcome back to ICAN Physics Academy. Now, in this class, we are going to see 5.12 from a fifth lesson. Let's enjoy the class. A short bar magnet has a magnetic moment of 0.48 Tesla. So, M equal to 0.48 Joule per Tesla. Give the direction and magnitude of the magnetic field produced by the magnet at a distance of 10 centimeter. Okay, so distance is 10 centimeter. Now convert the centimeter into meter. So 10 into 10 to the power minus 2 meter. Okay, from its center of the magnet. First question, along the axis. Okay, so along the axis. So what is the formula? B equal to mu naught by 4 pi. Mu naught by 4 pi into 2m by d cube. Okay, so here the distance is taken as d. So that we can write d cube. Okay, mu naught. So what is the value of mu naught? 4 pi into 10 to the power minus 7 divided by 4 pi into 2 into m. So what is the value of m? 0.48. So 0.48 into so divided by d cube. So 10 into 10 to the power minus 2 whole cube pi 4. Okay. So 0.48 into 2. So it becomes 0.96. So when you go for this one and cancelling this one. So finally you can get 10 to the power minus 4 is the magnetic field. So many Tesla. So what about the direction? So let us consider this is the magnet, south pole, north pole. It will be the axis. So the north pole produces the magnetic field which is acting radially outwards. So the direction of the magnetic field is along the axis and also away from the axis. Okay. The second one is along the equatorial line. So the first one is for axial line. The second one is for equatorial line. Okay. So what is the formula to express? So mu naught by 4 pi m by d cube. So mu naught 4 pi into 10 to the power minus 7 divided by 4 pi into m, that is 0.48 divided by d cube. So 10 into 10 to the power minus 2 the whole cube. So 4 pi. So we are getting only 0.48. So 0.48. So when your power is going to numerators and the denominators, finally we can minimize that. We can get 10 to the power minus 4 is the magnetic field. So many Tesla. Now we have to calculate the magnetic field along the equatorial line. Okay. So it's north pole and it's south pole. So the line which makes 90 degree with the axis, then it is okay. So the north pole produces and the south pole also produces the magnetic field at the point P at a distance of R. So the resultant field is acting in this direction, that is north to south or opposite to the direction of magnetic moment. Okay. Do you get it now? Do you any doubts? No doubt.